In this recording, we're going to take a look at simplifying complex fractions. And before we begin, we have to talk about what a complex fraction actually is. And it's just an expression of the form a over b over c over d. Just a fractional expression over fractional expression. And here we have a couple things that can equal 0. They're not going to influence what we do with the techniques in this section, but down the road they're going to come into play. So we have 3 examples to look at today. And here's an example of a complex expression. We have a fraction 1 over y and then 2 over y. So it looks kind of messy. And I'm going to show you 2 techniques, 2 methods for doing this. In method 1, you treat the numerator and the denominator separately. You're going to use the techniques that you learned in the last section about adding rational expressions, and then we will divide as we did in previous sections as well. Okay, so we're going to use method 1 here. So okay, let's get rid of the notes here. So we're going to treat the numerator and the denominator separately from each other. So I see in the numerator I have 2 plus 1 over y. And I already know that my least common denominator is y. It's the only denominator that appears. So we can simplify this as 2y, 2y over y plus 1 over y. And same thing in the denominator. Y is my least common denominator, and I have 3y over y minus 2 over y. Okay. And I can simplify both of those. The numerator is now 2y plus 1 over y. And my denominator is 3y minus 2 over y. That's a minus sign. And now we just have a division here. I have a fraction divided by a fraction. I know how to deal with that. That means that I'm going to take the reciprocal of the second fraction. This is the same as 2y plus 1 over y times y over 3y minus 2. And I already see that something very nice is happening here. I have a common factor, y, here in the numerator and denominator. They go away, and I end up with 2y plus 1 over 3y minus 2. And there's nothing else I can do with that. That's all set to go. So we're in good shape. So that's method 1. Here's method 2. In method 2, you take the numerator, you're going to take the numerator and the denominator, and you're going to multiply them by the least common denominator of the fractions that appear in both the numerator and denominator. So again, we're going to identify the least common denominator of both the numerator and denominator, and we're going to multiply both expressions by that. And we'll see what that does here, and then we'll try to simplify what we have. So let's get rid of these rules here. So this is method 2. I will tell you that I actually like method 2 a little bit better. You'll probably see why as we start going through these problems. But if I'm looking at it, I have a y and a y. That means the least common denominator in this problem is just y, nothing too fancy. And what method 2 advocates for is that you're going to multiply both the numerator and denominator by y. And that's legal because y over y is just 1, and I'm allowed to multiply expressions by 1. We'll see what happens. This y is a distributive property across the 2 plus 1 over y. I just end up with 2y plus 1. Same deal here. This y gets distributed to both the 3 and to this fraction, and I will end up with 3y minus 2. And there is nothing else I can do with that. So we got that pretty efficiently by multiplying by the least common denominator of the numerator and denominator. They're not all going to work out that simply, but again, I think that that method works pretty nicely. And that's the one I'm primarily going to use here. So let's look at example 2, and we're going to use method 2 for this one. I have to take a close look at my denominators. I see x's and y's, and x squareds and y squareds. And again, my least common denominator is the product of all the factors raised to the highest power with which they appear. I have x's and y's, and the highest power of each of them is the second power. So my least common denominator is x squared, y squared. And I'm going to multiply both the numerator and the denominator by x squared, y squared. And if you want to try that before I do it, you're free to pause this video and see what happens here. Okay. So my numerator, again, we have a distributive property. This has to get distributed amongst both terms. So I have x squared, y squared here. When I multiply that, or I divide that by x, I'll be left with xy squared plus, and now I'm taking my least common denominator and multiplying it by this term. Y's will cancel, and I will end up with x squared y. So I'm done with that numerator. Okay. In my denominator, I'm going to take this x squared, y squared, and I'm going to multiply it by both terms here. And again, it's a distributive property. In the first term, the x squareds will cancel, and I'll end up with y squared. In my second term, I see some things that cancel, and I will end up with x squared. Okay. Do I see anything I can do here? Well, I do see a little bit of cleanup. Let's see if there's any cleanup in this problem at all. I do see a little cleanup in that the numerator and denominator can both be simplified. In this numerator here, I can factor out xy, GCF. And if I do that, I'm left with y plus x. The denominator here is just the difference of squares. Y minus x, y plus x. Oh, isn't that nice? And isn't that interesting? And the plot thickens. Y plus x, they're a common factor. They go, and I'm left with xy over y minus x. Okay. So you just have to keep track of what you have, and again, your factoring skills have to be kind of sharp. One last problem. Well, this problem has some negative exponents in it. So first of all, it doesn't look like a complex fraction right now, but I need to rewrite it so it is a complex fraction. X to the negative second means 1 over x squared, minus I have 2 over y. So I'm really just removing these negative exponents and rewriting the problem. And then I have y minus 2x squared. So I notice on the denominator here, I really don't even have a fraction. I just have y minus 2x squared, and that's okay. So the least common denominator here, I do need to identify my least common denominator, is the product of the denominators that appears. That's x squared and y, so yx squared, or x squared y, either way you want to write it. And I'm going to multiply numerator and denominator by x squared y. And I'm running out of space here a little bit, so I try my best. I'm having a little trouble writing on the screen here. There we go, x squared y. And you have to multiply both of them by x squared y. You can't just multiply the numerator of something by x squared y. It has to be both. Okay? So let's take a look at what happens here. In my numerator, I have a little bit more space here. In my numerator, x squared over x squared cancel. That leaves me with y minus. When I multiply x squared y by the second fraction, the y's will cancel. I will have 2x squared. Now, I could be tempted to distribute this. But this is where you have to look ahead a little bit. I'm not going to distribute it. And I think you'll see why in a second. I have x squared y minus 2x squared. You see why I didn't distribute it? Sometimes you have to look ahead in these videos. And lo and behold, I have the same exact factor in the numerator and the denominator. And they can cancel. And if you had distributed that, you probably would not have seen it. So sometimes you have to look ahead and see what might potentially cancel in these problems. And this just simplifies as 1 over x squared y. So we're just on to the next piece of this. So we're looking at complex fractions. Not that difficult if you've mastered the last two pieces. And I hope you have some fun with the problems.